so wet clay, which then proved the link in the sort of footprints that these emus and other birds left, with the similarity with the dinosaur footprints that we can see here. So this is the slab of rock today. It's on display in our gallery. I actually photographed this afternoon. So we do still have this rock, and you can see you can see that these are footprints made by an animal with long straight toes, just as this emu, a long straight central toe particularly, and these are footprints that we can relate today back to probably a theropod dinosaur. Now, when dinosaur footprints were first found, of course, that was predated the description of dinosaurs. In the 1830s, when Edward Hitchcock was starting to discover and describe these footprints that he found, that he'd been shown in America, at that time, they very much considering that these were the footprints of birds. In fact, I think these were the ones that they thought had been made by Noah's raven as it went out to try and find land after the Great Flood. Of course, since then, the science of footprints and dinosaur trackways has come on in great leaps and bounds, and there's lots of new techniques which we can use to match footprints up with potentially the animals that could have found it. Although dinosaur footprints are very often not actually very well preserved. These on this slab and some of the ones that we have, I'm going to show you tonight, are very well preserved. Others are very poorly preserved, because if you think about how a footprint, if you're walking through wet mud or wet sand, quite often if the sand or the mud is too deep, the footprint will close in after you. The sides will collapse, or if it's very wet, it will just flow back in again, or if it's very deep, it will close back in. The ideal circumstances for a footprint like this to be preserved are very shallow, sort of half an inch or so of just the right dampness of mud or silt or sand. And that allows us then to see a fairly perfect imprint of the foot. And this is actually showing us that the foot itself, quite often usually when we're looking at fossil bones, we're seeing the bones inside, the skin is not preserved. So a good footprint can be said to be showing the underside of the animal's foot itself, the skin impression almost. So these footprints that we have, the first ones that were found, they are tridactyl. They have 3 toes. This long central toe equates to the same shape as a theropod dinosaur. These are about 20 centimeters, 25 centimeters long or so. And we call those, we call these Anchisauripus. And that's a name that we give to the shape of the footprint itself, not to the dinosaur, because there could very well be several different types of dinosaur of the same size and shape, and the footprints they would leave would be very similar. So that's where future discoveries will help us fine-tune what dinosaurs actually made what footprints. Now, occasionally you will look to find the bones, the actual fossilized bones nearby, and that will give you a little bit of a clue. These are the nearest bones we have to those footprints, and this is a jaw that was found only about 10 miles away, although the rocks it's found in are again a little bit adrift, so possibly up to 5 million years younger. So this is a single jawbone. We have part and counterpart for it, but both sides are hollow. So the fossil itself has disappeared out to the middle. It has been tentatively been given the name Zanklodon, although that name isn't really applicable. And there are thoughts that although this is probably a theropod dinosaur, it is just possible that it might be some other form of reptile that as yet unestablished. We only have the jawbone. We can tell it's carnivorous. We have these lovely backwards pointing sharp teeth. So it was very definitely a carnivorous dinosaur or reptile. So we like to think that it's probably a dinosaur. It suits us at the moment to call it such. And hopefully one day we can find other bones similar nearby and possibly find more of this animal. But so far this was found 120 years ago. So no sign of it yet. Apart from one single finger bone that was found down at Lavenock. So this is, again, 20 miles away, not the same animal, maybe not quite the same age. So similar sort of size and shape animal, very probably theropod dinosaur of the same sort of size and shape. This was found in the Rhetic bone bed. So a shallow marine setting for this one. So we can say that there were one or more very probably lots more varieties of theropod dinosaurs that were walking around South Wales around about 220, 210 million years ago, and of this sort of size, so around about 2 meters tall or so. So that's really all we can say about that particular dinosaur footprint, but we do have others. This slab was found again in the last part of the 1900s, the 1800s, found very close to the slab that I've just showed you. And it has the same footprint on it in the top left-hand corner, this same Anchisaurus footprint. Whether it's from the same animal, the same bedding plane, there is no way of telling. They were found within a mile of each other. It's really nice to think that, but on the other hand, we just cannot tell. But it also has two other footprints preserved in it quite well. And these are footprints we would call Eosauropus. As you can look at them, you can see particularly the bottom one is a completely different shape, much broader footprint, toes of a broadly similar size. So no long central toe. And the toes are curved in this, and this relates to an animal that's a lot heavier weight. This is a weight-bearing foot. The footprint in the middle, the toes, there's a hint of them being curved, so it may or may not be of the same animal again, or it could be a completely different animal. Again, this slab we don't actually possess, it's still in private ownership. We've got a few casts of it, but they're not that good. Work still needs to be done on this one. And it would be very nice to actually go back to the original quarries, but most of them have been filled in and built over. So that's not very practical. So this was probably made by an animal such as Platyosaurus, a sauropodomorph dinosaur, one of the predecessors of the big sauropods. But it may not be Platyosaurus itself. That isn't really established in the area by bones. These were found in Germany and across some parts of the rest of Europe, but it's the nearest thing we've got if we try to match the bones themselves up with the footprints. So it's a fairly good match. I mean, if we want to go and find footprints today, the very, very best place is Bendrix Bay near Barry. You can still see footprints there. It's an SSSI, so they are relatively well protected, we hope. The rocks are from the Mercia Mudstone group, so this is Norian age, towards the end of the Triassic-ish. And these flat-bedded terrestrial red sandstones and mudstones here each represent as a separate flooding event across these Triassic deserts. If you're going to go and visit here, you want to go down on a day after some bit of rain or after a high tide or with a low angle sunlight, because if you go down on a nice hot sunny day, you are not going to see them. They are not that easy to spot. But if you can get them when you've got these little puddles of water in, then you can see you can often see trackways quite well. And it was it was here that we've been finding the majority of dinosaur trackways over the last 40 odd years or so. This is what some of the bedding planes look like when they're spread out. This one was helpfully coloured in by somebody, I don't know who, a number of years back. Somebody had tried to colour in the different trackways. And this was at a time when some of them were actually, someone was actually trying to illegally lift some of these. You can still see the marks on this at the side to the left here, where crowbars were being used to lift some. Luckily, we got most of those back, but even so, on this beach, there are 10, 12, 15 different layers that have been documented with footprints in. So, you know, if one layer does erode or get damaged or removed, heaven help us, there are other footprints which often do appear underneath as these are removed. So this trackway is now gone. This was photographed about 20 years ago, so I think this layer has all but disappeared now. But we have lifted a few layers in the past, and these are now on display in the National Museum. So with illustrations of some of the dinosaurs that might have made these footprints. So we have a few trackways which can be looked at by the public. And this was the first trackway that was found in the 1970s. There are at least 4 different types of dinosaur tracks that have been found on Brendux Beach. And Chisaurus that I showed you earlier. There's also a much smaller theropod type trackway called Gralata. It's about half the size, about 15 centimeters or so. Also, again, with this long straight toe that we learn to recognize. And Eosauropus, the much larger, weight-bearing, broad, curved toed foot. And some of these even show handprints. and this is a factor which would preclude Platyosaurus from being the maker of these, because studies of the Platyosaurus skeleton show that it couldn't get its hands flat enough to use its hands for locomotion. So Platyosaurus itself was a bipedal dinosaur. So the fact that we have these quadrupedal trackways mean we are looking for a different culprit for at least those prints. And some of these seem to have 3 toes rather than 4. So again, an animal that if it had the 4th toe was holding that above the ground. And then a 4th type of print, Evozoum at the bottom here. And this is the one which it's more recently described. And it's the one that came into the news in January this year. So this track was pointed out to me in January. It went on social media for a few hours and went pretty crazy on social media before somebody said, I really think you should take that off and contact the local museum. So this was over a weekend in the middle of lockdown. I was sent this photograph like this. And my first thought was actually that this is too good to be true. It's somebody's been having a go and carving these things, because we know that people do carve images of fossils down there. But I went and checked, and no, it is genuine. It is a totally perfect. It is the most perfect dinosaur footprint we've ever seen from that site. It's not a squelchy type that's all fallen in on itself with it, you know. You can see the claws, you can see that the claws on all 4 toes. We think that this little bit at the top here is very probably the claw or the thumb claw. You can see the muscle pads, and of course, looking at the muscle pads and having them this well defined, it means we can work out where the joints of the animal were, and therefore put dinosaur bones back into these footprints. So this was found not on the rock ledges at the top where we normally look for them, but it was on a slab right down mid-tide level. So thinking if this was in January, this was very much at risk from the winter storms. So we had to work quite fast to get permission from Natural Resources Wales and the landowners of the site, the British Institute for Geological Conservation, and we got all the paperwork signed off within 2 days. and got the specimen moved, lifted, split from the top of this bit of rock, and just the top section then moved away to safety, because our main fear was that this rock was quite small enough to be moved by the winter storms and would disappear completely. So we could then allow the press a field day at it. Unfortunately, as they always do, the thought of a 4-year-old child finding a footprint like this down on the beach was something that they loved. So little Lily here, who was out walking with her father and said, "Hey Daddy, what's this?" So she was on all news and by Zoom for across the world. She's a lovely little girl. She's a total star. So, you know, we got a lot of publicity from that. And by May, I think we were able to get the specimen back into the museum safely and on display as well, where it is in the main hall. So now we have a lovely display. Public can come in, children can come in and see it and read all about Lily's discovery. So once we had it back in the museum, we were able to see that on the same slab, we didn't just have one footprint, we had a second one ahead of the first. So we're able then to try and establish a trackway, measure the distance between them, look to see whether we had left or right. And as it happens, yes, we have first a right print and then a left print ahead of it. The second one is very, very faint, but it's there. And you can see that they are the same print, and that they are mirror images of each other. And we can use the measurements of the length of these footprints, which are 11 centimeters, and then the length between them, the stride length between the prints, that to help us estimate first the hip height of the animal, and then potentially an estimation of how fast this animal might have been walking. So we think it was probably about half a meter tall or so, and walking at sort of our sort of walking pace, really. So not running as we have some running prints down there. No, just strolling along, enjoying itself through the deserts. So we call this, we can assign this to the name Evozoum. There are 2 species of Evozoum that have been described, one from Italy, one from America. And I'm hoping, now we've got it in the museum, that we can do some better measurements on this and plot it and see whether or not it's a good enough match for either of those 2 species, or whether or not we could possibly say that it doesn't match and therefore might be a new species for Wales again. But we haven't had it that long, and obviously on lockdown and furlough, we haven't been in that much to be able to study it. It's a fairly good match for Evozoum as a group. The characteristics include this very large muscle pad at the base of digit 2, which we have, and also this little channel within the muscles, between the muscle pads at the base of digit 4. And again, we've got that showing on this footprint as well. So we have high hopes that this is a good Evozoum, and that we can compare it very well to the 2 existing species. So what made it? We're always being asked what made these things. The most likely is it is some sort of basal sauropodomorph dinosaur again, and obviously that's the one that we would like it to be, because you know people like dinosaurs better than they like other reptiles. They've never heard of these other things, but there is the outside chance that Evozoum has been linked to this type of early crocodile called a cruratarsum. So we're hoping that it'll prove to be a dinosaur in the long run, but there is very little way of telling. So since then, obviously, people have been sending me their fossil footprints that they've been found from all across Wales. 1 or 2 of them are footprints. The one on the left here is another Evozoum, again from Bendrix Bay. All the ones on the right are not footprints. They've been found as farther afield as the Menai Straits. So that people are finding footprints in all sorts of different rocks all over the place. So that's just something we have to put up with as curators, is people sending us strange things, but you know, they're interesting in their own right. So we do have other footprints, not just the Bendrix ones. There is a locality on Barry Island which I'm not going to say to anybody exactly where it is. I do try and keep these things a little bit protected, but we have on this one site, this one bedding plane, we have 6 or 7 prints. Again, at least 2, if not 3 different types of dinosaur prints on this site. I have yet to get down and map them and measure them properly and document them, but they're there. We know they're there. So that's another one to add to the picture. Penarth, this time last year, about last August or so, again in the middle of one of the lockdowns, you might have caught a bit of press from the originator from the Natural History Museum. Some of their curators got wind of the fact that we had these structures down on some of the bedding planes on Penarth Beach that we'd known about for 12, 15 years or so. And one of the local residents told them that they were dinosaur footprints. And so they came storming down with a film crew and started investigating them. Now, we're still sitting on the fence about these locally. I don't know a single local geologist who is 100% convinced about this. They are hollows in a marley limestone, well, not a limestone, I would just say in a mudstone, really. And some of them have this pinkish alabaster mineral, an evaporite mineral, which infills them. Now, not all of them do. And we still really need to establish the methods of this alabaster formation, whether or not this evaporite mineral is forming within puddles of the desert waters within footprints, or whether or not these clumps of alabaster are actually forming, pushing the sediment out and forming into clumps, and then dissolving and leaving these hollows behind. That is what some of our local geologists suspect. So again, this is something that we're going to be looking at in the next year or two. This is photogrammetry done by the Natural History Museum curators, part of the paper that we've written about it. And they think that there is a regular spacing of these quite irregular hollows, which might just possibly be a trackway. Some of them may show digit impressions, others don't. They all show these raised edges, but again, not all footprints show raised edges. So we're just not totally certain about this at all. There might be some that are, there might be some that aren't. So if those that are, could well be Eosauropus again, this quadrupedal herbivorous dinosaur. But, you know, again, this is something that we're still working on. We do have quite a good set of trackways in another locality just along the coast. Again, I'm not going to tell you where. Several prints, at least 2 trackways with 4 or 5 prints in each, quite very definite dinosaurs. So this is something we've been working on the last few months. So we're hoping that this can be published just as to notify what this is. So we can put all this together to come up with quite a diverse Triassic fauna of not only dinosaurs, but probable other reptiles as well, walking around these deserts, leaving their footprints in these evaporating pools. But it was a time of great change. The continent of Pangaea was breaking up, and as this continent broke up and America pulled apart from Europe, sea levels rose, flooded across Great Britain, across Wales, leaving islands for a while. We had a nice little archipelago in South Wales, which then flooded again. And this change of sea level initiated a change of climate as well. It would have been a lot wetter, a lot more favorable to dinosaur diversity. You know, that this new group of dinosaurs would have diversified greatly, and this was one of the drivers behind it. So these Jurassic seas, generally nice and warm, shallow, high in biodiversity. And we can put together a picture rather than deserts across South Wales, where I'm sitting tonight. We would have had a climate much more like perhaps the Greek islands, together with the odd marine reptile as well, leaping out of the sea. Yeah. We also have faunas existing on these little islands. The quarries that digging into the Carboniferous limestone locally has dug through, most of them have dug through the remains of cave deposits, cave systems, which existed 220 million years ago. So these little islands, made of Carboniferous, had these cave systems on them in which animals such as the first earliest mammals like little Morganeucodon there and others, and little lizards, sphenodonts, other reptiles, were living within these caves, sheltering in them, perhaps bringing their prey into them, or possibly just getting washed in within these storm events. But however the pockets of bones appear, they are certainly quite productive, some of these fissures in these quarries, and we see many pockets infilled with these mostly disassociated bones and teeth material, illustrating quite a diverse fauna across this age, across this area. We can't establish an exact age for it. There have been datings ranging from Rhaetian at the end of the Triassic right through into the early Sinemurian. And it's quite possible that some of these fissures, these cave systems, were active for several million years, and might have spread across the whole of this age until they were finally drowned, but with the Jurassic seas, as they would have drowned across Wales in the Sinemurian times. But we do have little dinosaurs in these fissure systems as well. This is a dinosaur that was found in 1952. It was found on several blocks, so we probably have several individuals. They're juveniles. They've been given the name Pantodraco after the quarry that they were found in. And they are semi-articulated, which is what is great. They weren't just these disassociated bones and teeth, as so often we get. And this one particularly shows the skull and the neck of this little tiny animal. So if we try and reconstruct, again, we've got a juvenile animal, again, very, very small, possibly bipedal, and teeth very, very dissimilar to the theropod teeth, little tiny bladed leaf-like teeth, probably some sort of omnivore eating insects, plants, or anything else it could come across. And it might have looked something like this. Pantodraco caducus, this one. So bringing us then right through to the early Jurassic, the established early Jurassic at Lavernock Point. And this is the big find in 2014. It's a brilliant area for fossil hunting along the whole of this coast. Like every other rock has got bivalves and a few brachiopods and ammonites and occasionally corals and echinoids in, and marine reptiles as well, ichthyosaurs, plesiosaurs. So we have a fully marine fauna in the rocks at this particular point. The terrestrial rocks are going below this, off to the side here. But at this point, this cliff fall right in the middle here, in 2014 revealed something really unusual. We had long bones, which when cleaned up proved to be the hip and leg assemblage of a dinosaur in these marine rocks. So this is an animal which must have been washed out to sea and then drowned before it became too disassociated. So we have the hip, we have the femur as well, and we have the vertebrae associated with it. There were several blocks found within that rock fall. This is the arm, the arm and the chest of the animal. So we have gastralia as well as the finger bones, the claw, and even part of the back of the skull here, the basiocipedal bone at the back of the skull. So quite an amazing find here, and the skull as well. I mean, if you're going to show the public anything, you find a dinosaur, if you can find the skull, that's the best thing for the public. And although this looks a little bit of a mess, we do have some of the bones from the back of the head here. We have both cheekbones. The animal nose-dived into the sediment, and the skull split apart, and both sides of the nose here. And if I zoom in, you can see the nose of this animal with several teeth, some teeth up the side here on the other side of the jaw, and this brilliant tooth here, which if I zoom in again, you can see the detail and the preservation of this animal. Okay, this was a meat-eating dinosaur. This was a little theropod. Its little sharp serrated teeth here were ideally suited for meat. So there were various other bits found as well. So the guys that found it did a really good job of hunting through this pile of rock debris to find all these extra bits and pieces. And we still have high hopes that a few extra bits might come up. This left foot was found several months later, and we have high hopes for more bits being found in the future. So this was donated to us in the museum. It's on display again, the four main pieces. We've got about 30% of the animal, certainly enough to reconstruct it. Here we go. We've called it Dracoraptor. It's a completely new species and genus. Nothing like anything else that's been found. And it's quite important because this lived 200 million years ago, right at the very base of the Jurassic, at a time when dinosaurs were diversifying. So these are very early types, but very important for the future diversity of dinosaurs. So this one is quite an important animal. And for those who are into cladistics, which I'm not, I'm afraid, you can see that Dracoraptor has been plotted onto this tree here and comes out as one of the earliest neotheropods. So the slightly more advanced group of theropods over and above these very, very early forms. So that's the cladistic side of it. So we reconstructed Dracoraptor. We called it that because of the dragon on the Welsh flag, the dragon thief, and Hannigan after the family who found it. And we've also given it these little tiny tendrils of feathers. So we know that later theropods had decent feathers. They had fully formed flight feathers. Some of them, like Archaeopteryx, could fly, and they gave rise later to birds, of course. This was one of the very earliest in this lineage. So we think there's just a possibility, although there's no evidence, there's just a possibility that this little animal might just have had some sort of tendrils or proto-feathers on its side. So we can link this in then to our story of dinosaurs across South Wales, from the deserts at the bottom in the Norian through to as the sea level starts rising and we get lithologies which can produce, can preserve bone. We do find various bits, the jaw of this megalosaur type dinosaur, and also this finger bone, the little prosauropod here. And then as the marine conditions become fully established, we're still finding dinosaurs living nearby on these islands. So we have a very good lineage of dinosaurs, well established, and we're hoping that, you know, with the 2 or 3 new discoveries that people have found in the last decade or so, that we can add to that. You know, we're working with public and with amateur collectors more and more, and hopefully, you know, more dinosaur discoveries will crop up, and we'll be able to add to this picture, and we'll be able to work on the footprints as well, and link some of these in to other footprint discoveries. So I think that is our little model of Dracoraptor. So do come and see it if you're in Cardiff at any point. Come and see the footprint, come and see Dracoraptor, come and see me. And I think that is me sort of done. So thank you.